support. Between
Okay, everyone. September 8th to October 13th, I think that's our next. For those of you who have been up north, that's one of my favorite shots taken by a Yukon astronomer, Schwatkele, looking north. And yes, the auroras are like that. It's part of the Yukon River. Technically, it's the Lewis River, but everybody calls it the Yukon. So Klondike is a corruption of the native name, which is Klondike or something like that. I can't pronounce it very well, although I've had some people say I pronounce it perfect. And that was for a river that feeds into the Yukon River, the Klondike River up north. That's where the gold rush was. Up we go. So, start off with a solar system diagram. This is a straight screenshot from heavens above. And I'll talk a little bit about Venus, although I much prefer seeing it in the evening sky because I'm not a morning person. It's there morning and it'll be there for the next 5 months, shining like a street light. Jupiter's moons, we got some good International Space Station passes. And I always think this is the best time of year to see this stuff in the Milky Way. You can moon out of the way fairly well this month, especially by mid-month. So naked eye or binoculars. And I don't do much about the telescope stuff because I'm trying to write stuff for paper for people who don't have scopes. And anyone here who has a scope knows that better than I do, so what's the point? On we go. That is the solar system viewed from above. That little inset that pops out shows the inner solar system. Yellow is the sun, where the blue dot at the right side. And you can see Mercury and Venus between us and the sun. Mars is that outlier over on the left. And if you look at the entire solar system, everything but Mars is on the right-hand side of the sun. Does anyone remember the member of the US House of Representatives who was representing the, I think it was the Mariana Islands, one of which is Guam? And he complained in the House that if Guam got any more people moving to it, he was afraid the island was going to collapse. And I'm not making that up. He did say this. I think a lot of people face palmed on that one. Anyway, yes, the center of mass in the solar system is still within the sun. Even if you put everything on one side, the sun outweighs everything by 100 to 1. So the center of the solar system, I won't say the joke I did 3 months ago, is still the sun. So Venus. This is a shot from Stellarium, and boy, I like that program. That is tonight. Well, that was this morning at 6 o'clock. And you can see Venus and the moon up here right at the top. Right beside the little green buoy is, that says you are screen sharing, is Jupiter.
Is it possible to look down that hinge set, just in case it's being recorded?
I don't know.
You just drag it with a that will collapse it. Have to do that with that little minus sign.
Yeah, that'll do it.
Okay.
And you can slide it up as well.
There you
Or
go.
down. Yeah.
Cool. Thank you.
Okay. So, between us and the sun, it's just works. And the evening sky just tingles. Anyway, if you were south of the equator, you would have been able to actually see it every night. Some nights as an evening star and as a morning star the next day. Because it would have been, well, south of the sun, so higher in the sky in the southern hemisphere. I've seen it happen in the northern hemisphere. Because Venus's orbit is tipped at 8 degrees to our orbit. So when it comes between us and the sun, the last time it did, it was above the plane of our orbit. You could see it when it went down. You could see it when it came up in the morning, which is kind of cool. And if you go far north, it's circumpolar. Anyway, that's good for the southern sphere, but not here. So there is September 8th and October 8th. Same time, obviously darkness. End of the winter. And the moon's still there. Or it's come back there rather. You can hear Sun and Orion up there. I will choose Rigel. There he is. And Venus is still ahead. It is pulling ahead of us. We're catching up to it, and all the stars are doing this. There's November 8th. And Venus is still in the same position. Now you can see Arcturus and the moon. These are a month apart. You know, the moon's right back there. And finally, December. So you won't be able to get away from Venus if you're a morning person. And yes, there are still people who, I mean, it's so bright. I've had lots of people convinced that's not a star, that's an airplane, that's a plane. Where are you? But most people think it's an airplane. No, it's just fun. And of course, you probably know that when it's near inferior conjunction, and it's a slim, it's also big. It's 1/30th the size of the moon. And you can see it as a crescent with binoculars if you can study them. Anyway, this is the ice thing. This would be this morning at 5. I put the grid on here. Each mark is 1 minute apart. So Venus is almost 1 arc. The moon is 30. So half a degree. There. So next meeting, October 13th, Venus will be about 2/3 the size it is now, because it's pulling ahead and moving away from us. It does that. Next, Jupiter. It's nearing opposition, so at that point it's visible all night long. One of the coolest things I've done in a long time was when we had Comet Neowise in the sky. That was July 2020, I think. And I had the club's image stabilizing binoculars. I think they're 8x30. And they're the ones I handed over because one of the kids swiped them. I hope someone meant get them clean.
Yeah.
I did show them on to people when I was down at the Davis Strait Pier when Neowise was in the sky. Everybody's doing fine properly. But talking to a lot of people, 4 hours a night, you meet a lot of people. I could point, say, okay, there's the comet. There's the comet. You know what that is? That's Jupiter. And oh, cool. Pretty in the sky. And I would hand them the binoculars and say, okay, put your finger on this little dimple up top. I get it in the binoculars, and they're tough to use. They don't feel right. And then see Jupiter, squeeze that. And bing, the image isn't doing this. They are, but the image isn't now. I said, do you see those three little stars spread out on both sides? Yeah. Those are its moons. And a couple of people down here dropped the binoculars. It was just mind blowing that they could be the moons of another planet. And you think, now you know what Galileo thought. So this is September 12th. It's quite a good show this month, if the weather holds up. And I'm picking midnight. So this is 1 second before midnight on 12th. And they're quite spread out. So you've got Ito to the right, Europa a little bit further out, Callisto, which is the furthest one, way out to the right, Ganymedes on the left. And yet, 5 days later, this is all the same scale, haven't zoomed in or out. They're all squished just on the left side of Jupiter. Oh, yeah, you're right. Hey, we have a new asteroid. Now, Jupiter is 15 degrees above the projection of Earth's equator. So for us in the north, this is good because we can see it nicely. Saturn is low because it's further along the ecliptic, it's down low. And what's going to mess up Saturn, so I can't remember when, we'll be seeing its rings edge on, which means they're invisible. And apparently that confused some astronomers. The back point was like, what are those things? Because they disappeared. And it was like, okay, now what? They're gone. They thought it was a triple planet at first because you can see a blob, a blob, and a big blob. And there's dark things in between. Well, that's the gap in the rings. And as soon as it moves to the point where you're looking at them edge on, because it goes around the sky like this. And as soon as you see it edge on, you can't see the rings anymore, and it confused people terribly. Until somebody finally figured it out. So there's a squashed Jupiter, all the moons in this. Also this month, we get to see a bunch of passes of the space station. Technically, it's not astronomy, but that's okay. I like it, so it's in. It's going to do a neat pass on the 15th at 8:55 in the evening. It'll come up and move up and to the left, right through those stars. And those three stars that come off Antares lab, I forget the names, something, and they sound Arabic, and the bottom one is Fang. It's Chinese, that's where that name came from. I looked at it and I thought, okay, you can't make this up. The coolest thing about the orbit of the space station, they launched it from Baikonur in Kazakhstan, which has a latitude of 51 degrees north. That's the same latitude as London, England, and Calgary, Alberta. And I've lived in both places. And I got to watch the Zarya, that first module, the Unity module they launched, come over London when I was living there, 6 months, I think, in 99, I think. Anyway, and you could see it coming up out of the west, and it was just before sunrise. You could see it moving, and there was an aircraft moving along right below it. They were going exactly the same angular speed, and they were equally bright. Zarya didn't leave a contrail, but the aircraft did. And that's because they launched it from a place with the same latitude. So the launch due east and it goes down and around to 51 south and comes up. Meanwhile, the world's turned underneath it, but that orbit is tilted 1 degree, same as the latitude of your launch position. So you can see the same thing in Calgary. It was really cool watching one of them re-enter over Calgary, shuttle. Because 4 minutes after it left a purple streak, you hear the double sonic boom as it went at Calgary, and it landed in Florida 8 minutes after it went overhead. You'll see it in the morning for the first half of the month, and then in the evening for the remainder of September. It's just, where is the Earth? Because we go around the sun, but the orbit doesn't do this as we do. It just does this. So we go in and out of phase morning and evening. And yeah, I've said it before, check heavens above to get the exact time for station passes. They adjust this about every 10 days to 2 weeks. Because there is a little bit of drag from the upper atmosphere and it slows down and speeds up. So they boost it because you don't want to create a new fireball. Now everyone knows what this is, right? At the upper right is M31, the Andromeda Galaxy. And that brightish star in the middle is Mirach, M-I-R-A-C-H. That's in that big arc that ends up with Pegasus. And up above 11 o'clock off the screen would be the right-hand V of Cassiopeia. So that's the pointer down to this picture. If you go and not do it there, can you see the cursor? Yes, you can. That's correct. And if you want a binocular field of view, you see another bright star. If you go equally as far again, you see not quite so bright star. Oh, wait a minute, what's that fuzzy patch? Well, that's M31, Andromeda Galaxy. You can see it naked eye, but it's neat in binoculars and awesome in a scope. What I have done was when I was doing my astrophotography thing on the top of the mountain, after 2 hours in complete darkness, not even a red light, I could see M33, Pinwheel Galaxy, naked eye. And just about exactly as far in the opposite direction. If you can find M31, you can get to M33 and you can't see it in binoculars. It's there. It's just a fuzzy little patch, but it's there. So I think this is the best time to see the Milky Way because it's better than the moon in the sky. And we're heading for new moon. So that'll keep it dark. You can see Auriga in the northeast, Perseus, Cassiopeia, Cygnus, so on, all the way over to Scorpio and Sagittarius. Hurry if you want to see Scorpio. Another month and it's pretty much gone. And then as the night progresses, the whole thing turns and you can see Orion coming up, which is along with Jupiter and Venus. It is. For most people, it's lovely. Anyway, there's the text how to find Pinwheel Galaxy and Andromeda. But I just talked about that, so fine. And the rift is always kind of cool. If you go from the northeast and go up and you see Cygnus, you notice the whiteness, the paths, and there's a dark part, the Great Rift. And that's just dusk in between us and most of the stars, right in the plane of the Milky Way galaxy. And it obscures the view. You can also, here's some of the other stuff. You can do this now and with binocs. You can find M13 in binoculars in purchase. And M22 and the wild duck cluster, which is cool. I thought it was globular the first 3 times I looked at it. Apparently it isn't. But naked eye, I see something out there. And it looked fuzzy. So
Where is that in?
yeah, it's that way from Scorpio Sagittarius. Southwest, about there. I'm not, I start off all that, but I don't know.
Are you in the corner of the field?
Yeah, well, that doesn't help me, but now you know. So, and then of course in the morning, I would look at big nebula in Orion. And that doesn't make your heart beat faster. You haven't got a pulse. So, any question? Anybody at home with any questions?
Home where the center begins.
Okay, the third galaxy is on the right-hand side, Sagittarius. I've written about it. I keep remembering, okay, I did that. No, I didn't. I did it for the newspaper. You look to the right-hand side of Sagittarius. This time of year, and you can see where the center of the galaxy is, not because you can see it, but you can figure out from looking at different stars where it is. There is a black hole there, which the Cousy Imaging Project, I can't remember the name. It's radio astronomy. They're using massive radio telescopes and enough computing power to turn the lights out in the northern hemisphere. And they have
long baseline.
yes,
Okay.
yeah. They have imaged in radio frequency the black hole at the center of the Milky Way galaxy. And they've portrayed it as black and varying shade brightnesses of orange. Now this is 27,000 light years away, the center of the galaxy. And the image that they've made is of an area that would fit just inside the orbit of Venus. It's like 120 million miles, miles, and it's 27,000 light years away. So this is like one of the atoms on the head of a pin on the moon. It's that small, and they've imaged it. And it's not voodoo either. They've used the Hubble telescope to take repeated pictures of that little piece of space. And there are some big, bright stars in there that are moving at appreciable fraction of the speed of light. And they're doing parabolic orbits about a point in space. And they're coming in from all directions and changing direction around this area. There is something there that can take 10 solar masses and do this with it. 4 million solar masses inside a small part of the solar system. That's how condensed that matter is. That's the black hole at the center of our galaxy. And these guys have imaged it.
Wow.
So, okay, I'm, so if that's it, I'm done. Thank you.